All right, well, welcome everybody. Michael Benz, I'm a solutions architect. I guess I shouldn't hit the microphone. For the embedded opportunities within SUSE, and working with Brian here.
Yep, I'm Brian Gardner. I work on the alliances team as well, solution architect, technology strategist. I work with a lot of our hardware partners, some embedded partners every once in a while, some software partners too.
Okay. All right, so we're going to talk about enabling compute at the edge, at and from the edge, and back and forth. So this is TUT1274. So what we're going to cover here is the terminologies, topologies, considerations, the facets that you need to look at for pushing to the edge, for compute, for data gathering. What we won't cover is the edge device component stack, so the hardware.
The actual IoT devices?
Yeah, the low-level stuff. And we will have some scenario walkthroughs where we show how you can start with a basic solution and then build that up to scale, and how you can support that at scale.
So let's start off with a little bit of scoping and context. How many of you have heard about Industry 4.0? Good, a few people in this room. And there's lots of embedded links throughout this presentation, so when you download it, you can click about it and learn about it. But really, they talk about that as the smart factory, right? That's the next generation of the industrial revolution, where they're automating as much as possible, taking data in, learning from it, and doing the right things. Industrial Internet of Things is very closely related to that. But you know, if you're IT related and you've been in that space for a long time, pretty much all we're saying is you're distributing the compute farther and farther, okay? There are lots of consortiums, working groups on this topic. If you go to the Linux Foundation, there's the Edge one, there's Open, you can go to OpenFog, EdgeX Foundry, Everywhere Software Framework. There's lots of places where you can go get information on this topic, okay? There's lots of projects that are working on trying to figure out how to do this. If you want to go down the path of OpenStack, right? Because, you know, a private cloud kind of thing, they want to figure out how to extend down to the edge too, how to deal with that latency, how to spread a compute node way down there. You can also go down that path of Kubernetes, right? If you want to figure out how to do a cluster like that, or how to spread workloads there, how to do maybe perhaps a name node or something down there. There's an IoT Edge working group. There's things like KubeEdge, there's Knative, there's even a new open source project that just happened called K3S, which is a very slimmed down version of Kubernetes that can land on a single node. If you're familiar with Minikube, it's even slimmer than that and almost easier to deploy. And what we're going to try and focus on, though, is a kind of a coherent strategy of explaining the topics and explaining the different flows and whatnot. And we would like to make this more and more interactive as we go down this path, because we'd like to get feedback on things that you're very interested in and you'd like to see us include. Okay.
All right, so the technology and topology. So, you know, if you look at the stack, you've got cloud, you've got your core groups, you've got your edge gateways, and you've got your IoT clusters. So that, you know, thinking about it from a network topology standpoint, you can push all the way out to the edge where you're gathering sensor data, and you can do something with it there, or you can send it all the way back to the cloud. But the amount of data that we're getting nowadays, sending everything to the cloud just doesn't scale. So as we push down, the hardware capabilities at the edge are increasing drastically. I mean, the compute capabilities, the storage, you can do an immense amount of work at the edge. Take that data, pass it back to the models in the cloud, train the models, and then download updates of AI frameworks at the edge. So you can do something with that data real time, as well as continuing to train the models and get smarter and smarter. You know, creating IoT clusters, so clusters of devices that you then have one level up, more gateways to take that and deal with it. The core could be your internal data center. It could be a group of gateways that's one level up doing, you know, some other extrapolation of the data. And then obviously the cloud. Do you have anything else you want to?
No, and just to kind of echo one thing that we've really seen happen on the edge gateway devices and whatnot, they really are becoming much more
server class.
Server class. I mean, there's Xeon processors that you can run down there, and so they can run bare metal, they can run virtualized workloads, or run containerized workloads. So So one of the things that we really want to focus on for this presentation is there's basically three kinds of flows that are really relevant. The first one is the data, right? And Michael's talked about that. You've got all these devices spewing data towards a gateway. All right, now what are you going to do with that? Where are you going to send it? How are you going to deal with that, right? The next one is, and this is the one that as we work with partners and whatnot, this is the one they come back to us and they say, okay, now we have N number of gateways and way more IoT devices, and we've got the core. How do we manage all those devices? How do we have coherency in the configuration management? How do we deal with all of that space? Then you also have the model flow, right? And this is actually, if you think of it in terms of like an AI or a machine learning sense, so models have to move throughout this infrastructure as well. Because one approach is, of course, you could just do all of this in the core or in the cloud if you wanted to, right? But the whole point of an edge gateway is to react to data very quickly, and it could be a control function, right? All right, and that might be the very smallest workload that you have sitting there to do that, to send a signal to a PLC and turn off, an air conditioning or turn something on that fell off or whatever, right? But then there's also the next level of model is data's coming in a time series. I want to react to that data and do the right thing collectively or alert somebody or things like that. So you've got management flows, you've got data flows, and you've got model flows.
Okay, so the exclusions, what we aren't going to cover in this is the actual IoT devices, so the hardware, the gateways, even though they provide the data flow and are often the target of the models in the workflow. As far as target platforms, x86, 64 and 64-bit ARM, and the possibilities for the workloads are just immense. I mean, the catalog is just huge and growing daily.
Yeah, we could spend a whole conference just going through all the applications that might be out there.
Yeah.
Right?
So.
Okay.
So, you want me to do this one?
Yeah, you can go for this one.
All right, so we just went through and listed some of the hardware. These are some of the vendors that I'm actually working with, and their gateway devices or edge compute nodes. Some of them are smaller, like the AdLink stuff, Eurotech, but then you get into the Dell Edge gateways, which you probably have seen those. HPE's Edgeline, Supermicro's got everything from Atom-based to Xeon-D-based gateways. Embedded Pi, this is a new partner I'm working with that is they're taking the system on module Pi, and they're building an industrialized gateway that can be outdoors and monitoring anything from gas and oil and gas meters to flow to pressure and reacting based on the workload. Plus a variety of single board computers that are x86 or ARM based. And then you can add in GPU, connectivity over Ethernet, cellular. We've got Bluetooth, and then storage. Variety of storage can be added.
So then as we go up, and the stack and whatnot on this gateway, right? There are lots of folks that do build your own, do it yourself kind of thing, and they might use tools like Yocto or something like that. They might use a distribution that already exists. They could be a specialized purpose, real-time kind of distribution. They might use a community-based distribution because they're thinking about scale and the cost associated with that. They might use an enterprise-based Linux, and we have things like the Just Enough operating system that's a nice fit there. And then you want to figure out how you're going to host all these different kinds of workloads. And it's just like being in a data center, really, because the workloads may come only in one form factor, right? And it could be, for us, like an RPM package, right? Or it could be a virtual machine, right? Maybe it only comes wrapped in a virtual machine that happens to run Windows, so I need a hypervisor there. Or it could be delivered as a container, right? And that could be part of a data flow operation. So any of those things, they could come in that flavor. And what we're really finding, though, is most edge gateways are going to need to run a combination of those.
Okay, if we keep moving up, so and Brian talked to this a little bit, so the packaging, so how's the workload delivered? Is it a VM? Is it a container? Is it a OS image? Is it running bare metal? You know, how's it delivered? How's it maintained? How's it updated? That's, you know, you start looking at the management aspects.
And just kind of that little comment down there at the end. I mean, if you think of the movie Aladdin, basically we got a data center and itty bitty living space, right? Go ahead.
Okay. All right, so starting with the simple design, which everybody's probably familiar with. You've got your gateway, and you've got something talking to it, sending data, and you've got some admin client that is maintaining that gateway. So you start looking at the data flow. You know, how is that data getting back, and what are you doing with it? Is it, you know, just spewing data and you're just taking it and storing it? Are you plugging it into some cloud API? Are you pulling for it, or is it sending real time? How do you manage it? Is it, you know, some SSHing in and doing user admin? Or are you plugging it into some existing infrastructure, or is it something you built? You know, back to the models and the workflows. Are you taking advantage of something that's already there, or are you building it yourself?
And before you go on, just how many people have done something like this at home? Yeah, I figured there's several people that have played with it at home. Yep. Okay. So what are the concerns once you go down this path? Because that's what happens. You know, engineers do this and whatnot, and then they hand it to their company and they say, look, I can do all this kind of cool stuff. And then as you go through, whether it's IT or whatnot, they're going to respond with some concerns. They look at it, okay, that's kind of difficult to scale unless you want to manage an SSH into 100 of these, right? You going to do that for me? Probably not. How can I replicate it? How did you build that box again? Okay. Data retention, right? Is it going to sit on that box? Are you going to send it somewhere else? How are you going to keep the integrity of that? Let's say one of those boxes go down. What are you going to do with that? How are you going to get that back? You didn't even have a recipe to build it, right? And then, of course, you know, the CISO is going to get involved and go, this is not a very secure situation. Let's figure out how to do this in a more secure fashion.
So now we move up the stack. We add more capabilities. You know, connected to the edge node, we start looking at more robust data flows. You know, data discovery, how you refine that data, what do you do with it? How do you process it? Where does it go? You know, the management is, you know, I talked about this a little bit on the previous slide, but are you using some standard-based management tool? Are you growing it yourself? You know, and again, the model. It's like, what is the model? What is the workload? What are you doing with that data?
Okay.
So,
I'm gonna let you take this one too.
So this was the demo that I had running on the floor, one of the demos. So I had containerized Apache, and I was talking over Bluetooth to a little sensor pack that was gathering sensor data, so like temperature, humidity, light, things like that. But so what I'd done was I used systemd to spawn the container. So it's not always running, it's only running on demand. So you can actually containerize workloads and use systemd to spin them up as needed and process those and interact between containers. You know, so taking the data, ingesting it, you know, maybe spinning up TensorFlow and doing something with it.
Okay, so now we've gone on to the next stage. You know, how are you going to begin to scale this up? How are you going to, all those considerations, right? So, you know, again, look at the color coding and whatnot. The data's kind of the yellowish, the management's cyan, the model's kind of purple and whatnot. You can start to see that obviously as they scale, there's more connectivity things that we need to figure out how to deal with those IoT devices, right? They could be SIO connected, they could be NFC, you know, they could be Bluetooth, all kinds of options. Yeah. And unfortunately, there's more PCI slots in there, so you can just add cards and continually grow that space. Okay, so data starts coming into that, and it could be pulled, or the IoT device is maybe able to push that in. Now you got to figure out, okay, what am I going to do with that data long term? Am I going to have models? Am I going to train AI? Am I going to do something with it? So the data is probably going to get pushed somewhere else, because while these boxes have good functionality, they do have a finite amount of storage. I'm not going to store the data there forever, over 10 years, with hundreds of IoT devices spewing data at me, right? And I probably don't have the resources there, even from a compute standpoint, to do all the learning there as well. So I might start pushing up to the core, if that exists, whether it's the stacked bunch of gateways that have more storage capabilities or whatever, or whether that's your core data center. Or there's capabilities, and I think you kind of talked about this, or you had this almost running in the booth, where you push directly to the cloud, right? Yeah. right? Because there are services in the public clouds where you can actually push that data up there, all right? Once you have all that data spread across all there, now you need to start working on that model, that workload, right? How do you train? Where do you do the training at? And then how do you get that model propagated back down to where it needs to be, wherever that is, whichever one of those layers. But now, from a management perspective, you're starting to think about, okay, there might be a handful of these gateways out there that are dealing with these clusters of IoT. So I can probably still remotely access it, but that's not the right answer, but that's probably where you're at right now. But you're starting to figure out, okay, I've got to deal with configuration management. I want to make sure that I can always access these things from a given host, or I want to SSH, I want to set up firewall rules. I want to take that systemd thing and only respond when I get packets from this MAC address, not from hackers' denial of service approach, right? Okay? So those are the things you're going to start considering.
Yep. Yeah, so then you start looking at the concerns. Scale across many aspects of, deployment, management, everything we've talked about. The data propagation, the visibility, the integrity of that data, the reliability, resiliency of the hardware, of the workflow, of the solution, availability and performance of it, and serviceability and security.
So as you start to think about addressing those concerns in this more scaled out environment, you want to think about coordinating that data flow. Have any of you messed with an open source project called Pachyderm? No? I would encourage you to go look that one up, okay? Pachyderm, like, the scientific name for an elephant. Yep. Look that up. It basically, if you're familiar with a Git technology or something like that, it knows the data's coming in, and it can deal with the incremental amount of data compared to what it has in its queue in whatever way you want. So it could do the data cleansing at that point. So, data packet comes in and it looks at it and goes, that's within my control limits, okay. And it can put it into the store, right? And then the next step is that you can do batch movements of data, okay? So it has a lot of capabilities and allows you to do this data pipelining in a very programmatic way. Great tool, and it's actually sitting, I believe, in our build service. One of the other concerns or things that you're going to have to start thinking about is the encryption, the data at rest, the data in flight, right? So how are you going to deal with that? So if you had a tool, something like Pachyderm, you could say, first thing I do is I make sure that this packet might be authentic. It's within my control limits. Okay, let me encrypt that, and then I can move it forward, all right? So you can start to do all of these things with something like that. And then as we've worked with some of our partners, they've looked at entire AI kinds of architectures. And what they've come to the conclusion is that having something like an S3 protocol is a nice way that almost every application in this kind of space can normally talk with. So having that in place is a nice way to move things, and then that also gives you the ease of the ability to move it to the cloud, right? Whether it's OpenStack or whether it's even something like SUSE Enterprise Storage. All right, at the management level, and I kind of pointed at you guys saying how you're going to recover, how you're going to roll back, because stuff's going to happen on these devices because they're remotely accessible. So you want to start thinking about how can I roll back, and again, with something like just enough operating system, right, built on ButterFS, does snapshots, you can do rollbacks, things like that. That kind of answers some of those questions. That's not the only answer out there, but it is one that might be very good for you. I already talked about the access controls. All right, so now the model piece of it. You really need to start thinking of this as a CI/CD pipeline in terms of the model, how you create things, where's the training data at. I'm going to create a model, and then I'm going to move it down, and then setting up corresponding registries, repositories of these things so that as gateway number 1 needs this model, it can get to it, and as gateway number 2, it can go to its data, its model, and whatnot. Okay.
So one of the other things we didn't talk about, we talk about encryption at rest, but trusted execution. Are you using a module, TPM module to do that, to verify the code that's executing is trusted? Are you using trust zones in the processor? Those kind of functionalities are all available to you for implementing in your design. All right, so strive for the managed state. So we take the same scaled out design that Brian was just talking to, and we add SUSE Manager to this. And what that does is it allows you to manage. So if your company's already using it in the cloud and in your data center, it pushes to the edge. It just extends. These boxes are just another node in the network. So it allows you to provision, to deploy software, to reprovision systems, to create images. It could be containers, it could be OS images. It just gives you the whole DevOps, CI/CD. It just closes the loop as far as giving you that capability to extend all the way out of your data center to the edge. Well, I mean, we keep talking about the data, ingesting that. What do you do with it? Sorry, go ahead.
So we tried a year or two back. We tried scaling OpenStack to this sort of problem, and we would run into some hard upper limits on how many, like it was like 900 nodes or something, and then it was just forget it because the databases wouldn't handle the loads of all the monitoring traffic. When you say manage, are you just talking about simple like provisioning and startup operations, or are you talking about like a continuous monitoring management type thing?
Well, so the capabilities of SUSE Manager, it wouldn't be continuous monitoring of the systems per se, but it has an API it uses Salt. So you have the ability to extend its capabilities if you need to do something additional outside of our functionality.
And it also has, the tiering capability too, right? So as you stretch this cluster even farther, right, you might have a central, SUSE Manager might actually exist over here in the cloud, but there could be a proxy that's near the site where these guys are, in an oil field or a factory too.
Yeah. So the system, you can have the single pane from one node. It just doesn't scale as far as sending out patches to 1,000 nodes. So you set up proxies to distribute the updates.
And just along your lines of the OpenStack question and stuff, we have some OpenStack experts in the room over there. They might be able to give you some more answers about managing that sheer number of nodes and whatnot too. So feel free to come up afterwards.
Okay. Anything else on there?
I think the only other thing is, again, thinking about the models and the tiers of how you do that, and thinking about it in a very DevOps mindset, right? Some modeling tools, some machine learning tools and stuff like that, you can incrementally add learning data, some you can't. So you need to start thinking about those things as the ones you choose, and what's the proper use case within this distributed kind of computing environment.
So the concerns, I mean, they stay the same. You still have security. You still have the provisioning and re-imaging of the nodes to make sure that they're up and keep them running. How do you recover if it fails? Connectivity issues. So dealing with 3G cellular connected boxes that are out at the edge of way out at the edge of some network, or low bandwidth and intermittent connections. If you've got a cellular connection to your gateway, you don't want to be pushing gigabytes of updates across that and paying for that. So how do you mitigate that? So SUSE Manager, you detect, you schedule when you want to do the updates, and you pick and choose which updates you want to push. It gives you that capability. All right, let's see if we can run this. So there's no audio with this, but it walks you through logging into SUSE Manager, what the UI looks like. So it shows you how to get to the system overview, so you can see what systems are out there. So this particular one, it selects this top node, shows how many patches are available, what packages, the configs, lets you drill down and do an audit. You can see if there's any security fixes that need to be applied. Shows the servers that need it, lets you select that and actually apply the updates. So here you can take a look at the products that are available and select, say you want a juice image and you want to, did you have a question? Or are you stretching? No. Oh, okay, no problem. So you, as it gets here. So say you want a juice image, you want to provision a system. So you pick that product and you select the node and push it out. And that's the gist of it. That's the short 30-second
Yeah, and that was literally, SUSE Manager running on a VM, managing a gateway that was far away. So.
Yeah, hold on. Okay, so takeaways. What would you like to see from SUSE for IoT?
Yeah, so we're asking for our takeaways from you.
Yeah.
Not just delivering stuff.
How can you contribute? Share your experiences, share your needs. Join a community or a working group. Get involved, drive what you want, what your needs are, drive it through.
So this is actually where we'd like to poll you and see if there's something that triggered something for you, or if there's some certain request or some package or something that you think would be relevant in this space. Or if you have any general questions.
Or comments.
Feedback is welcome as well.
Any questions? Guess we're a little late on that one. Some of the resources. So the demo's down now, so you can't stop by booth 19, but there is a hands-on guide for a hands-on session that I was part of. I can send that to you if you want it. Just give me your email address and I'll email it. It walks you through adding systems, updating the service packs, various other aspects of how you use SUSE Manager. Pertinent sessions. Take a look at some of these that have already happened and some that are coming up. Go join them.
Well, they're mostly probably done.
They're probably
by
done
now.
now since they already.
But
yeah.
because things are recorded,
Yeah.
this is a pointer to some things that might provide more context
Yeah.
or more tool-specific things.
Yep.
Brian, I do have one question.
Yep.
So a lot of the infrastructure that you all talked about obviously leverages existing SUSE infrastructure, kind of, that's core business. If we're going to move higher in the stack, we're not going to move to a standardized data analysis kind of package on those edge gateway devices. That's probably not the kind of application suite that we would want, because that requires us to move into an application vendor status. However, in terms of providing application infrastructure that could be enabled for those types of analytics, is that an option for us? Have you looked at that at all? What kinds of tools or libraries or development recommendations we would need to provide there for here's your open source tool set to enable those types of apps?
Yeah, we actually have a long list of feature requests for our products to include some of these AI machine learning tool sets. Some of those may not make it into the product, but they could likely land in Package Hub, which would be a great place to first have them there. And then of course, we provide the technology so you can build a container with those, and then you could run them as close as you want to the edge. You may not run the entire thing at the edge, but you may just run, so for instance, there's an Intel tool, chipset and tool called Movidius. I don't know if you're familiar with that. So it is basically, the form factor is either the mini PCIe or you can have a USB device. And what you can do is you can send the data up, create a model, and download the data into this. And so I'll give you a kind of a weird kind of example because I do haunted house stuff, okay? What I'm going to do with that is I'm going to do body recognition, okay? As people come through the haunted house, I'll train that so that I can know kid, mom, dad. We're going to target mom for the scare, okay? That's when the thing's going to happen. And I can download that model to the Movidius thing. It can be plugged in as a USB device on my Raspberry Pi and have the camera there just watching people by and then go trigger effect, skip effect, okay? So.
Yeah, or some of the other examples I've seen similar to that where people walk into a building that's got access control, and if someone's coming in with like with the ski mask on, hiding their face, that they can lock the doors and they can call the police, or they can lock out the elevator, those kind of behaviors.
Yeah, and a lot of that is, if you think about the public cloud, a lot of that's available with our public cloud partners, right? So you can get a whole data science workflow already established from AWS or Azure. A lot of it's based on things like R Server and Spark, and it's just leveraging the machine learning that they've already built. So if you want to do recognition, that logic is already there. Now, admittingly, you're sending that data up to the cloud, and that may not fit your use case, but it's there and it's available.
But again, you have that potentially that device that you can download the model back to that's already learned, and you can just run it. It's a runtime thing. You're not trying to learn at the edge. You're trying to use it at the edge.
But as you send the data, as you send the data up, it gets smarter, and you keep downloading newer versions, and it gets smarter at the edge.
Depending on which
And
ML
which one
tool
you're
set,
doing,
if
yeah.
you can do the incremental or whatnot. Yeah.
Yeah.
Speaking of SUSE Manager, will there be a special tailored solution for ARM devices or any other not x64 or ARM devices, so when the new chips are arriving, so I shouldn't have to build it for myself, and smaller distributions, not the 4 gig packages, I don't need it at all.
So you have the ability to take the standard offering and scale it and trim packages out to your needs.
And you can also support managing ARM devices already. Yeah, I mean, we didn't scroll down far enough in the table when I was showing that, but those are just channels that are available via Customer Center.
Yeah.
SUSE Manager is happy to mirror that for you, make those repositories available. You can register an ARM device. And
Yeah, I had the demo that I had set up,
Yeah.
I had 2 Raspberry Pis and
Yeah.
a couple of Intel boxes, so on all the
so
channels.
as long as it's ARM64 for now. Okay.
So I don't know if you guys have read the book Click Here to Kill Everybody by Schneider. But the big issue in IoT and the edge and all is security, because all these devices get rooted and the manufacturer's not going to patch them. So you guys are saying what packages would you be interested in, but you thought about how security problems have changed and what we can do about it? So are there intrusion detection systems that can scale to the edge? Are there innovative firewall structures or ways of detecting attacks and mitigating them that might apply?
There are a lot of ways to do it. It just really depends on the implementation you want to use. Yeah, so it's something as simple as just trusted execution of codes, then when malicious code gets launched.
Yeah, you can man trap different devices depending on where you decide to set up your infiltration points into your data, whether you're doing it at the edge or the core. And again, that trusted execution, firewall porting, I mean, all those things are capable, which is why it has to be established well in advance.
And also, I mean, even at the OS level and things, if you use something like the Btrfs and the snapshots, and you can basically do like we do with MicroOS, which is underneath our SUSECast platform, or you just use what will be labeled as transactional server. It's a read mostly file system. Okay, so now rooting it becomes harder. Okay, and I can always roll back to the last known good state. And so I can monitor in a configuration management mindset with something like SUSE Manager and say, oh, I see something has changed on that system. I don't trust it anymore. Let me roll back to the last one, which was good. Now, that being said, I'll also give you the downside of something like that. So I was involved with doing remote access to a partner set of systems and whatnot, and a rootkit got put on that system. The bad news is, because we do regular snapshots and stuff like that, and I wasn't involved with it for long enough, all my snapshots were contaminated. So then I fall back to I'm just going to redeploy SUSE Manager, okay? Get it back to a known good state again, some other way.
Just shoot it and re-image it.
Shoot it and hit. Yep.
Any other
Anything
questions?
else? I hope this was useful. I know we didn't talk like a package level or things like that, but again, that's what we would like your feedback on, what machine learning tools, what AI tools would be of most interest to you. Give us that feedback, okay? There's lots of ways to give us that kind of feedback. And also, again, look out in the open build service, so build.opensuse.org, see if those packages are already there. Then you can play with it, you can build containers, you can try it and see if that works. If it's not there, there's lots of developers in our community that can help you get that packaged and stuff, and we can start to play with it there as well. Okay?
All right.
Cool.
Thank you.